when we're when you're trying to evaluate a process, or we're trying to measure um, a property of a material or a property of an environment, we're going to typically use some type of measurement system. So if we can generalize, we're going to generalize all measurement systems using this model that's pictured below. Okay, so there's 4 stages within this measurement system. There's the stage where we're at the sensor transducer stage, right? All right, so we have the process. The sensor is placed near or within the process, and that sensor has a signal that gets transformed to probably into a physical signal that gets transformed into an electrical signal through a transducer. All right, that transducer the signal then gets put into a signal conditioning. So typically this is where we have amplifiers and we have filters that take that electrical signal and amplify it and filter it down. And then it goes, that filtered, amplified and filtered signal goes into some form of output, right, where we have that output signal is typically bring into a computer or data logging device. Right. In addition, that signal can be used to then go ahead and control. It can be used by a controlling process to then change the process until the thing that we're sensing improves or hits the target. Okay, so um, so a simple example of a entire measurement system is an analog bulb thermometer. Okay, so the sensor within the bulb thermometer is the internal liquid within the thermometer. Okay, so all this internal liquid, that is our sensor. Okay, all right. The transducer, all right, is the internal geometry or the cavity of the thermometer. Okay, so the transducer. So depending on how you change the uh, so the cavity of the thermometer actually controls the sensitivity of the thermometer. So depending on if the size of the bulb relative to the diameter of the cavity that goes up the thermometer, it changes how sensitive it is to changes in temperature. So if you have a very large thermometer, uh, it doesn't really change much with respect to temperature, so it could be used for a very large range. But if it's very sensitive to temperature, it probably has a very small diameter, and very small fluctuations in temperature causes the liquid to expand or contract. All right. So the last part after the signal conditioning part, which is a function of the geometry, is the output of the thermometer is based off of the gauge that's written off of the capillary, written over the capillary on the bulb. Okay, so depending on the scale or the level of the thermometer, which it's kind of hard to see now, so let me erase this. All right, depending on the level of the bulb, you can estimate the temperature that the thermometer is reading. Okay, so a very simple example of a complete measurement system, but it's a very the model of the sensor, transducer, signal conditioning, and output model is what we'll be using throughout this course to think about our measurement systems that we're using in both a theoretical sense on like the Monday classes, but also in the laboratories on Wednesdays and Fridays.